Okay, good morning. So, till the last lecture, we have covered the unit 3. So, today we are going to start the unit number 4, that is the special concrete. So, here written unit number 7, but actually this is the unit number 4. So, the unit number 4, title for the unit number 4 is the special concrete. So, there are many more types of concretes, depends on their purpose. So that how that purpose we are going to cast that concrete and we are going to use that concrete, that we will see in detail in this particular unit. So there are various types of special concretes are there. We will see one by one why these concretes we are using, what is the purpose behind we are using these various types of concrete. That part we will cover. So special concrete. So here the syllabus for the special concrete, which we have to in our as per the our syllabus is the review of the and behavior of the characteristics of the high strength concrete, high performance concrete, fiber reinforced concrete, mass concrete, lightweight concrete, and heavy concrete and precast concrete. So these various types of concretes we are using nowadays in our construction industry, but the purpose are very important. We are using that various types of concrete. So high strength concrete, so we required high strength at various locations where the heavy loads coming on our structures. So their bridges are there, so underwater constructions are there, so many more structures are there. Their heavy loads are there. Some of the railway bridges are there. So we know the weight of or load of the railway, weight of the train from the train on the our earth. So and for that we are constructing the structures for the railway crossing on the any nala, any river. So we have to construct high strength concrete for this particular regions. So high performance concrete. So if we consider the strength, then if the strength is come into picture, then durability of structure is also important. So high performance of concrete is also important. Some fiber reinforced concrete. So for the some of the structures we are using now replacing the steel by the fiber. So fiber we are using as a reinforcement instead of the steel. So such fibers we are using as a reinforcement in the concrete, so that fiber reinforced concrete is there. Then mass concrete. So have you seen very mass concretes like a dam structure? So the width of dam and length of dam, if you consider the mass concrete we have to require. The retaining walls are there, mass concrete is required. Then raft foundation is required. So 1 meter, 2 meter depth raft foundation we are doing on any side. So for that purpose mass concreting, म्हणजे concrete हे इतक्या प्रमाणात आपण वापरतो की तिथे स्टील नेग्लिजियन्स असतं, but the concrete is in mass requirement. So then lightweight concrete. So sometimes the weight of structure we have to reduce. So some of the slab is we are using slab of the hollow slabs we are using. Then sometimes if you talk about the our singly reinforced beam or doubly reinforced beam, so the center part of the beam, if you see about the depth of beam, so center part of the beam there is no any stress. So you have seen this triangular portion, triangular shape of the stress variation. So that triangular portion, it indicates the at the top and at the bottom tension and compression stress is there, but at the middle you have seen, are you providing the reinforcement at middle to the beam? No, we are not providing the reinforcement at the middle part of the beam. We are providing the reinforcement at bottom, and we are providing reinforcement at beam top of the beam. So middle part having the less stress. So that stress we can minimize by the hollow concrete. म्हणजे मधल्या पार्ट मध्ये कॉन्क्रीट वापरायचंच नाही, हॉलो पार्ट ठेवायचे की जेणेकरून त्या कॉन्क्रीटचे वेट हे रिडक्शन होईल. Then heavy weight. Sometimes high strength concrete we are using, so heavy weight concretes are also we have to construct. And precast concrete. So nowadays, if you see on any river, precast girder we are placing. प्रिकास्ट गर्डर म्हणजे दोन पियर वरती आपण डायरेक्टली प्रिकास्ट बीम ठेवतो. हॅव यू सीन इन दी व्हेरियस sites of construction on the river side? So precast beams, precast panels. So nowadays we are moving towards the this construction technology, precast, because on the site construction is the material handling is uneasy. मटेरियल हँडल करायला लागतात, लेबरची रिक्वायरमेंट साईट वरती जास्त राहते, साईट अनऍक्सेसिबल असते. अशा केसमध्ये आपण प्रिकास्ट कॉन्क्रीट वापरू शकतो, प्रिकास्ट कंपोनेंट यूज करू शकतो. सो दॅट प्रिकास्ट कंपोनेंट वी कॅन रिप्लेस इझिली, की त्या दोन पियर वरती इझिली आपण मशीननी तो प्रिकास्ट बीम ठेवू शकतो, त्याला आपण गर्डर म्हणतो. सो सच व्हेरियस टाइप्स ऑफ कॉन्क्रीट्स वी आर युजिंग फॉर व्हेरियस स्ट्रक्चर्स. सो this is the our syllabus of this particular unit number 4. That is the unit number 4 is the special concrete. So then what is general behavior of this particular special concrete? So the special concretes are prepared for the specific purposes. As we have discussed, the special concretes are we are preparing for the specific purposes, and the purposes are the lightweight concrete, then high density concrete, then fire protection concrete. So how we can protect the fire? So as in the last lecture we have discussed about the fire resistance. So aggregates are fire resisting material. So we are using the aggregate into the concrete. So aggregate is the manufactured by the from the basalt rock. Aggregates we are manufacturing from the basalt rock. So basalt rock having 900 degrees Celsius resistivity to protect the fire. म्हणजे 900 डिग्री सेल्सिअस इतकं जर टेम्परेचर ऍग्रीगेटला दिलं तरच ऍग्रीगेट हा मेल्ट होऊ शकतो. अदरवाइज वी कॅन सो दिस इज द फायर प्रोटेक्टिव्ह, सो ऑर फायर रेजिस्टन्स. सो कॉन्क्रीट इज अ फायर रेजिस्टन्स ऍज कम्पेअर टू स्टील. स्टील लवकर तुमचं फायरला सपोर्ट करेल. 400 डिग्री सेल्सिअस पर्यंत जरी हीट गेली तर स्टील आपलं काय होतंय, बर्न होतंय. पण जर 900 डिग्री सेल्सिअस इतकं जरी टेम्परेचर आपण दिलं कॉन्क्रीटला तरी कॉन्क्रीट बर्न होत नाही. सो aggregates are very fire protective. So fire protection is very important if we construct the concrete structure. Then radiation shielding, etc. These are the some specific purposes for construction of these special concretes. Then again concrete is again the versatile material that processing the good compressive strength. As we know, we are using the concrete for the compressive strength and steel for the tensile strength. So concrete is taking the is good in compression. So the process that versatile materials we are using, that cement, sand, aggregates or other materials for various purposes we are using for the making the concrete. So the concrete having the good compressive strength, but it suffers from the many drawbacks. If advantages are there, so disadvantages are also there. Why? Because good compressive strength is there, but low tensile strength is there. Then permeability to the liquid is there. Then corrosion of reinforcement is also there in the concrete. Am I audible? Then the modification what we are doing into concrete, that the concrete has been made from the time to time overcome the deficiencies of the cement concrete. Then the recent development of related to concrete in the material and construction technology, that is the significant changes in resulting the improve the performance of the concrete, and the wider that more economical use of concrete we are doing nowadays. So these are the some modifications into in the concretes are there. Again, if you see in the research front, so many more research is going on in various concrete, that is the concrete in research laboratories also there. and the improvement in performance of the concrete we are observing nowadays also. So then what are the various types of special concretes? So the various types of special concretes you can see here now. The lightweight concrete. This is the one of the type of the special concrete. Then high density concrete. High density. Dense concrete, it means there is no voids. There is no air gap. Dense, properly dense. There is no any voids, porosity, gaps. We have to give the chance to so we can say that is the high density concrete. Then plumb concrete is there. No fines concrete is there. Then aerated concrete is there. Then fiber reinforced concrete is there. We are calling as a FRC, fiber reinforced concrete. Then polymer concrete. Some polymers we are using for the because the concrete having the less tensile strength. So if we use the polymer, so polymers are having good tensile strength. So if we use the polymer into the concrete, they will get the high tensile strength. So the concrete is in good compressive strength, but in weak in tensile. So that if we use the polymers into the concrete, then what will happen? So the tensile strength of concrete will be increased. Then ferrocement concrete is there. So then high strength concrete is there and high performance concrete is there. So these are the various types of special concretes we are using nowadays. So that we will see one by one here. So difference between the ordinary concrete and special concrete. What is the ordinary concrete and what is the special concrete? So such type of question you will be asked in examination. So differentiate between the ordinary concrete and special concrete. So you have to make this comparison or differentiation, and you have to write answer such a way. So if you see the particular this slide, so there are we have compared the ordinary concrete and special concrete. So if you talk about the ordinary concrete first, so first point, if you see, the ordinary concrete is used for normal work like building, bridge, roads. Ordinary concrete is used for normal work like building, bridges, and roads. So if you talk about the special concrete, this type of concrete is used for special type of structures like nuclear reactor. Why nuclear reactor? There is a tremendous heat is there. So specific ordinary concrete is not required there in the nuclear reactors. Then nuclear reactor, buildings with acoustic treatment, air conditioning buildings are there. So there maybe we are using the special types of concretes are there. Then second point we have to differentiate, that is the ingredients of the ordinary concretes are cement, sand, aggregates, and water. So the basic ingredients of concretes are cement, sand, aggregates, and water. These are the four main basic ingredients. And as per the requirements, we are adding the admixtures, polymers, other many more materials we are using the as per the requirement. But for the ordinary concretes, these basic requirements are, basic ingredients are there: cement, sand, aggregates, and water. So if we talk about the special concrete, second point, in case of lightweight concrete or lightweight aggregates are used. So lightweight aggregates we are using. So again, in polymer concrete, polymer binder is used instead of water. So polymer binder that we are using instead of water. So it means we are not using water, like not that. म्हणजे पाणी वापरतच नाही असं नाहीये, but we are replacing some of the polymer binders for the replacement of water. So super plasticizer, some admixtures we are using. So that admixtures, what doing? They are maintaining the water cement ratio. जर आपल्याला 0.44 वॉटर सिमेंट रेशो लागणार असेल तर 0.40 वॉटर सिमेंट रेशो आपण मेंटेन करू शकतो इफ वी ऍड दी admixtures, polymer binders. So that is the special concrete. So then third, if we talk about the third point, that is the construction is carried out by conventional method. So whatever construction we are doing by the for the ordinary concrete or for the any construction project, So that construction is of by only conventional method. Conventional method means, so the concrete we are batching, mixing, then transporting, placing. So this is the method of the placing of concrete or any from starting mixing to placing. This is the process. But here concreting is done in the special techniques. In this, the special concrete is done by the special technique. So special techniques are there. So the concrete is made up in the RMC plant. Generally, if we do the concreting on site, what will happen? Site वरती जर concrete करत असेल तर बरेचसे प्रॉब्लेम्स फेस करावे लागतात आपल्याला. So labor mixing the water as per their requirement. So aggregate sands mixing as per requirement. कोणी तर एक पाटी जास्त टाकतं, कोणी एक पाटी कमी टाकतं. So this is the happen on the site. But if we mix the concrete in RMC plant, what will happen? There is a volume batching or weight batching is there. जेवढं कॉम्प्युटरला तुम्ही इनपुट दिलं वेट घेण्यासाठी तेवढ्या इनपुट आणि आउटपुट प्रमाणच तुमचं कॉन्क्रीटचं तेवढ्या मटेरियलचं वेट घेतलं जातं की जे बेल्टनं कन्व्हेअर करून आरएमसी प्लांट मध्ये मिक्स केलं जातं. सो दीज आर दी सम स्पेशल टेक्निक्स आर देयर टू मिक्स दी कॉन्क्रीट or to do the concrete. So that we are using in the special concrete nowadays. And I think at every taluka place one concrete mixer is now available as per my observation. मी तर प्रत्येक तालुक्याला आता बऱ्यापैकी कुठे ना कुठे तरी एक आरएमसी प्लांट व्हायला लागलेला आपल्याला दिसतोय. सो वाय इट इज रिक्वायर्ड? बिकॉज वी कॅन मेंटेन द क्वालिटी ऑफ कॉन्क्रीट. साइट वरती कोण कसंही कॉन्क्रीट मिक्स करतंय, कसंही कुठूनही टाकलेलं कॉन्क्रीट त्याच्यामध्ये रिक्वायरमेंट प्रमाणे डस्ट किती आहे काय आहे याचं कुठल्याही गोष्टीचं आपण calculations करत नाही. And that concrete, so that the concrete strength will be decreases. If the strength is decreases, durability of concrete is again decreases. So that matters are there. So the special concretes nowadays we are using, the reasons behind that, we can do the concreting in proper way and we can use the special techniques also. Then fourth point related to difference between the special concrete and ordinary concrete is the ordinary concrete, the properties of ordinary concrete like density, strengths are of the normal range. So whatever ordinary concrete we are preparing, the properties of that concrete are in like that, like the density of the concrete, then strength of the concrete are in normal range. But if we talk about the special concrete, the special concrete is having the good density, that is the density strength or higher range. For example, density of lightweight concrete is about 500 to 2000 kg per meter. So how much density of normal concrete? Density of concrete is 2400 to 2500, correct? 2400 ते 2500 kg per meter cube, म्हणजे 24 ते 25 kilonewton per meter cube. Are you getting? You know, so that density for the ordinary concrete is 24 ते 2500 kg per meter cube, म्हणजे 24 ते 25 kilonewton per meter cube. But if we talk about the special concrete, then the density of special concrete, the lightweight concrete is 500 to 2000. But if heavy weight concrete is there, the density is 3000 to 500 kg per meter. So this is the difference. 24 ते 25 kilonewton per meter cube आणि 30 ते 50 kilonewton per meter cube. There is a difference. So nowadays for some of the projects we are using this high strength or high heavy weight concretes are there. So now you have seen some concrete roads also in our Pandharpur area, nearby Pandharpur to Sangola, Pandharpur to Mangalwada, Pandharpur to Kurduvadi. Also, you have seen the roads. So these all roads are constructed by the concretes. So the depth of that concrete is a 40, almost 40, 100, 1 ते 1.5 फुटापर्यंत त्याची डेप्थ आहे, म्हणजे 40 सेंटीमीटर पर्यंत. So if you think about the 40 centimeter depth of this concrete, so this concrete will be the heavyweight concrete. So the density will be that density of that concrete will be automatically increases if we use such types of concrete. And last difference of this ordinary concrete and special concrete is ordinary concrete is economical because we are using whatever ingredients, cement, sand, aggregates, that are the normal ingredients we are using. But if we talk about the special concrete, so whatever ingredients we are using, that are the costly. Costly means cement असं नाही की इकडे वापरणारे सिमेंट तिकडे वापरत नाही, but some techniques whatever we are using for concreting, so that methods are the costly. So this is the differentiation of the ordinary concretes and special concrete. So many times this question will be asked in the examination for theory, because you will be appearing the theory examination in the offline mode. So such question will be asked in the examination, a difference between the ordinary concrete and special concrete. So you have to write such a way this particular differentiation. So then first type of special concrete is the lightweight concrete. So when this lightweight concrete introduced in the market, so in the May 2011, so recently 10 years ago, this lightweight concrete concept we have comes into the picture. So the density of this particular lightweight concrete is in between the 2200 to 2600 kg per meter, 2200 to 2600 kg per meter cube density. So in the last slide also we have seen lightweight concrete density is 500 to 2000 kg per meter. That is the depends on the your how much you have reduced the weight of that particular concrete element. So if you see this picture, so how looks the lightweight concrete? Ka manu upon lightweight concrete? Because we have provided some holes to that concrete, means hollow part we have kept. Light ka jhala concrete because we have provided the hollow parts to the concrete. So due to these hollow parts, what we have observed, so they reduce the weight of concrete. If reduce the weight of concrete, then what will happen? Automatically the cost will be reduced. Are you getting? So the cost will be reduced if we make the concrete element of hollow, then the cost, then the weight of concrete will be reduced. Weight of concrete will be reduced. It means automatically cost will be reduced. So this is the lightweight concrete. So due to that, your density of concrete will be reduced. Then this particular types of concrete is self-weight will be the it's a economical structural material, because we are providing the hollow part. So the self-weight of that particular structure or component will be the reduced. Then the dead weight of the structure also made up of this concrete is a large compared to the imposed load to be carried. So the dead weight, it means self weight of that component. So we are constructing concrete component for the building like slab, beam, column, staircase, or any other components we are constructing. So if we construct these components in hollow part or hollow components, if we construct, then dead weight of that structure will be reduced, and this concrete is a large we are comparing the imposed load to be carried. म्हणजे imposed load it means live load. So जो काही live load त्या surface वरती येणार आहे, it will be carried in the high as compared to ordinary concrete, and the dead weight of that concrete is reduced. म्हणजेच लोड पण जास्त घेणार आणि स्वतःचं सेल्फ वेट पण कमी. सो इट इज गुड क्वालिटी ऑफ कॉन्क्रीट नो, किंवा कॉन्क्रीट टाइप ऑफ कॉन्क्रीट हा खूप चांगला आहे मग. सो बट दिस सम लिमिटेशन्स आर देअर. जसं आपण स्लॅबला वापरू शकतो तसं हे कॉलमला वापरू शकत नाही. आर यू गेटिंग वाय? बिकॉज कॉलम इज अ वर्टिकल एलिमेंट, सो वी आर नॉट युझिंग दिस फॉर द कॉलम. The reason behind that, the column is a vertical member and this is taking a totally compressive load. जर total compressive load जर एखादा member घेत असेल तर त्या ठिकाणी आपण hollow part ठेवू शकत नाही. Are you getting? So we are not providing hollow part to the column. Why? Because the column is taking a totally compressive load, and for that purpose we are not providing, we cannot provide the hollow part. So some drawbacks are also there. मग तुम्ही म्हणाल की सर डेड लोड पण भरपूर घेतोय, डेड लोड पण कमी होतोय आणि लाईव्ह लोड पण भरपूर घेतला जातोय, मग हेच कॉन्क्रीट का वापरत नाही? बिकॉज देर आर सम लिमिटेशन्स. सो दॅट वी आर नॉट युझिंग ऑल प्लेसेस. सम ऑफ द प्लेसेस वी कॅन यूज दिस. देन द स्मॉल रिडक्शन इन द डेड वेट, रिडक्शन ऑफ द डेड वेट. म्हणजे या ठिकाणी आपण सेल्फ वेट किंवा डेड वेट काय करतोय? रिडक्शन करतोय. सो रिडक्शन इन डेड वेट फॉर द स्ट्रक्चरल मेंबर लाईक स्लॅब, बीम, कॉलम इन हाय राईज बिल्डिंग as we have discussed. So we can reduce the self weight of these RCC slab, self weight of the beam, self weight of the column in high rise building, and the result in this lightweight concrete is a considerable saving in the money and manpower. Manpower पण सेव्ह करू शकतो आणि आपण काय मनी ही सेव्ह करू शकतो. Why? Because reduction of the dead weight. If the weight of the concrete is reduced, जेवढं लागणारं कॉन्क्रीट आहे त्याच्यापेक्षा जर कमी कॉन्क्रीट आपल्याला वापरायला लागलं तर ऑटोमॅटिकली कॉस्ट and money we can save. So this is about the lightweight concrete. Again, this lightweight concrete have been made in the past to reduce the self weight, as we have discussed. Dead weight, it means self weight of structure we can reduce by using this lightweight concrete, and to increase the efficiency of concrete as a structural material. So efficiency of concrete we can increase as a structural material. And also the lightweight concrete is with a density in range of 300 to 900 kg per meter cube. So last slide मध्ये आपण पाहिलं होतं की 500 पासून 2000 पर्यंत kg per meter cube पर्यंत याची डेन्सिटी आहे, and that have successfully developed. So 500 to 2000 kg per meter cube density is there. So this is about lightweight concrete. So what is lightweight concrete? So generally lightweight concrete is the concrete which reducing the self weight or dead weight of the structural component. The structural components are beams, slab, columns, etc. And the density of that particular lightweight concrete we are reducing from the 500 to 2000 kg per meter. So why this is the most advantage of this particular concrete is what? We can reduce the self weight, we can reduce the dead weight of the structure, and we can take the maximum imposed load. म्हणजे लाईव्ह लोड तेवढाच घेऊन आपण त्याचं weight self weight reduction करू शकतो. So if self weight is reduced, then what will the final outcome? Automatically cost will be reduced. So this is about the lightweight concrete. So as we have seen this particular picture, so this is the made a block of the hollow block. So if we make the mass concrete for this block, म्हणजे जर तो जे काय आपल्याला होल्स दिसतात ते होल जर आपण पॅक केले किंवा ते होल जर भरले तर आपल्याला काय होणार आहे? वेट इन्क्रीज होणार आहे. वेट इन्क्रीज झाले की ऑटोमॅटिकली कॉस्ट इन्क्रीज होणार आहे. and concrete is a heavy material. If we reduce the, if we use this hollow part, then your dead weight of structure will be the minimized, so that we can reduce the settlement of foundation also. जितका बिल्डिंगचा वरचा लोड जास्त तेवढी सेटलमेंट पण फाउंडेशनची होऊ शकेल. Are you getting? So if we reduce the weight, then settlement will not occur. So some controversy points are also there. So then again, as we have discussed the advantages, but here we can see the details, detailed advantages of this particular lightweight concrete. So the first advantage, if you see, reduction of dead weight. As we have discussed, dead weight or dead load, whatever dead load of that component, what is, how we can calculate the dead load? Volume into density. Volume into density is the your weight or load. So that if we do the calculations of your volume, you can calculate the volume by length, width, and depth. And if we multiply by the density, then you will get the total load. So reduction of the dead load here, one of the advantage. Then second advantage is a smaller section of the structural member can be adopted. Smaller sections, so small section we can adopt by using this lightweight concrete. Then lower haulage and handling cost. म्हणजे आपण एखादा कॉन्क्रीट जर आपल्याला एखाद्या साइट वरून हँडल करायचं आहे, किंवा haulage, it means what, we have to transport that, so that is the low cost is there because the low weight is there. So then next advantage is increase in progress of work. If we use the low cost material, or sorry, low lightweight concrete, then the work of the progress will be the fast. Then next advantage is the reduction of the foundation cost. So in the foundation, we can use the some hollow part, so that we can reduce the foundation cost of the construction also. Then particularly in case of the weak soil and tall structure, as we have discussed in the last slide also. The structure tall आहे आणि soil weak आहे, we have discussed in last slide also. If the structure is tall and soil is weak, and if we use the lightweight concrete, what will happen? We can avoid the settlement of foundation. So settlement of foundation we can avoid by using the such lightweight concretes are there, so that the foundation cost will be reduced. The next advantage is a lightweight concrete has a lower thermal conductivity. So lightweight concrete has a lower thermal conductivity. It means it cannot pass the more temperature, thermal temperature, it cannot pass it. In case of building where the air conditioning is installed, the use of lightweight concrete will be result in the better thermal comfort and lower power consumption. So if we provide the hollow part to the some component, RCC component, so the thermal conductivity is also there. म्हणजे बाहेरचं टेम्परेचर आणि आतलं टेम्परेचर मेंटेन करण्यासाठी आपल्याला हेल्प होऊ शकते. इफ द मास कॉन्क्रीट इज देअर, देन तो पूर्णपणे एलिमेंट कॉन्क्रीटचा टेम्परेचरमुळे जर हीट झाला तर तो थंड व्हायला खूप वेळ लागतो. बट इफ वी यूज द हॉलो, देन इट विल, the heat will pass through hollow portions, so the lower thermal conductivity will be there in such a case. So these are the some various advantages of the lightweight concretes are there. So again, some of the advantages are there. So the use of lightweight concrete gives outlet for industrial waste such as fly ash, clinkers, slag, etc., which otherwise create a problem for the disposal. Then next advantage is it offers great fire resistance. As we have discussed, the concrete is a good fire resistant structure. So the great fire resistance is offered. That is the one of the advantage of this lightweight concrete. The next advantage is lightweight concrete gives the overall economy. Lightweight concrete gives the overall economy. Then lower modules of the elasticity and adequate ductility of lightweight concrete may be advantage in the seismic design of the structures also. So if modulus of elasticity is lower, then the ductility of the lightweight concrete will be the more efficient in the seismic design of structure. ज्यावेळी आपण अर्थक्वेक रेजिस्टंट स्ट्रक्चर डिझाइन करत असतो त्या केसमध्ये डक्टिलिटी मेंटेन होण्यासाठी जर हे लाईट वेट कॉन्क्रीट खूप इम्पॉर्टंट आहे. अँड हाऊ डक्टिलिटी विल बी important because the if the lightweight concrete is there, it means hollow parts we are providing. Hollow parts we are providing, it means the lower modulus of elasticity. So this is this type of concrete is having this such great advantages, so that we are using this lightweight concrete. But some of the drawbacks are there. Due to that, we cannot use every place this particular types of concrete. So then the lightweight concrete is achieved by 3 different ways: by replacing the normal mineral aggregates, cellular porous or lightweight aggregates. So we can use the normal mineral aggregate and we can use the porous or lightweight aggregates. Again, by introducing the air bubbles in the mortar. So whatever concrete or mortar we are using, in that we are introducing the air bubbles, and that is known as aerated concrete. Also, we can achieve lightweight concrete by omitting the sand fraction from the aggregate, that known is the no fine aggregate. As we have seen, two additional types of the special concrete, that is the no fine aggregate and aerated concrete. So this aerated concrete and no fine concrete comes under the lightweight. So these are the 3 different ways to achieve the lightweight concrete. So if you see the pictures of the lightweight concrete, such a part we can use to prepare these components, and these components we can place in a different location to minimize the dead weight and self weight of the concrete. So then lightweight aggregate concrete. So lightweight aggregate concretes are, if you see here, this lightweight concrete is divided in 2 categories. That is, the first is the natural lightweight, then aggregate, then pumice, scoria, rice husk, diatomite, then volcanic tuff, and foam lava. So due to this, the lightweight aggregates we can use. And next way to lightweight aggregates are this artificial lightweight, then aggregate, then this centered fly ash aggregate, then foam slag aggregate, then bloated clays, artificial cylindr, expanded clays, coke breach, then expanded perlites, and this exploited this vermiculite type of aggregates we are using as a lightweight aggregates. So if you see here, or you can see here sketch also. So these types of the stones we are using for the lightweight, because this is the naturally having lightweight. If we compare our basalt rock and these stones, so these stones are the natural lightweight stones. So these are the pumice. This is one of the natural lightweight stones. So that stone we can use in that particular concrete as an aggregate. So pumice is this is the one of the rock first type of natural aggregate. This is one of the rock of the volcanic origin, and this particular rock having the light colored or nearly white, and has a fairly even structure of the interconnected voids. त्याला voids असतात, त्याच्यामुळे आपण तो लाईट वेट असं कन्सिडर करतो. आणि the bulk density is 500 to 800 kg per meter. So the very less bulk density is there. So this is the, if you see the first type in the picture, the first type of rock, pumice, this first type of rock is having air voids, if you see, so that your weight will be reduced, and bulk density is 500 to 800 kg per meter. So second natural lightweight aggregates is the scoria. So the scoria is a lightweight aggregate of the volcanic origin, and they are dark in color. So the color of that is the dark, and it is slightly weaker than the pumice. If you see here, second rock in the picture, particular picture, if you the scoria having a dark color, and as compared to this pumice, this is the less weight is there. So then third is the rice husk. So again, if you see third image here, rice husk. So this is the some of the in the powder form, but this is not powder. Some small pieces are there. That rice husk, use of that rice husk is, or groundnut husk has been reported as a lightweight aggregate. So we are using that rice husk as a lightweight aggregate. Then next is the number 4, that is the sawdust. So if you see here, fourth sketch, that is the sawdust. The color is slightly red, faint red color is there. That sawdust we can use. That sawdust is used as a lightweight aggregate in the flooring and in the manufacture of precast element. So, but the presence of that carbohydrates in the wood, though adversely affect the setting and hardening of the Portland cement. So this is related to sawdust, and that we are using as a lightweight aggregate. And then next is the diamides or diatomites. So if you see this particular picture, so last picture, 5th number picture is shown the diamides. If you make the aggregates of these diamides, because this is also low or lightweight aggregate is there. So diamides is derived, it is derived from the remains of the microscopic aquatic plants called as diamonds or diatoms. So it is also as a pozzolanic material. So the pozzolanic material we are using as in the our as admixtures in the concretes. So that pozzolanic, so that is the one of the pozzolanic material. So if you see these 5 images, so these materials or these we are using as a natural lightweight aggregates. So why these we are using? Because this is the naturally lightweight, and if we use into the concrete, then what will happen? Our concrete will be also the lightweight. So then again, if you see, we have seen this is the natural lightweight aggregates. Now artificial lightweight aggregates. आपण एक बनवलेले काय lightweight aggregates आहेत. These are this centered flash, that is the pulverized fuel ash. Pulverized fuel ash is one of the lightweight aggregate that is the artificially we have prepared as a man. आपण स्वतः किंवा आपल्यासारख्या काही लोकांनी as a civil engineer नी हे pulverized fuel ash artificially तयार केलेलं आहे की जे lightweight आहे. So what is this pulverized fuel ash? So generally this pulverized fuel ash is collected from the modern thermal power plant burning pulverized fuel, and that is mixed with the water and coal slurry in skew mixers and then fed on the rotating pans, so known as pelletizers. and it will form a special or spherical pellets. So if you see image here, so these are the some pulverized fuel as we can see, and that is prepared or manufactured as artificial light weight aggregates, and we are using for the in the lightweight concrete. Again, these pellets are fed on the sensor sorry sensor at the temperature of the 1000 degrees Celsius to 1200 degrees Celsius, and due to this centering, the fly ash particles coagulate to form hard brick like spherical particles. म्हणजे याच्यापासून आपण पावडर फॉर्म मध्ये आहे, त्याच्यापासून आपण ऍग्रीगेट तयार करतो, and that produced material is screened and graded in and in UK it is sold by the trade name, that is the Lightech. So this is artificial lightweight concrete. First artificial lightweight concrete is the pulverized fuel ash. Second artificial lightweight aggregate is the foamed slag. So foam slag, if you see in the picture, particular picture, so the foam slag is available in the powder. So foam slag is a byproduct in the manufacturing of the pig iron, and this pig iron it is again porous and honeycombed material which reachable pumice. So the pumice la apan reachable we can do the we can place as a reachable to the pumice, that is the foam slag. So this is again artificial lightweight aggregate is there. The next artificial lightweight aggregate is the bloated clay. So bloated clay is again when the special grade of clay we have to use special grade of clay, and cells are here heated to the point of incipient fusion. There will be the expansion due to the formation of the gas will in the mass as a mass, and the expansion is known as the bloating, and the product so as formed is the lightweight aggregate. So bloated clay is a manufactured or prepared from the special grades of clay and cells. So whatever clay and cells we are using in the cements, manufacturing of cement, so that clay and cells, from that clay and cells we are making this bloated clay. So next artificial lightweight aggregate is the exploited vermiculates. So these exploited vermiculates are the again raw vermiculates materials are there, and that in the appearance and consist of the flat flakes. So this again by heating with the certain percentage of water, it expand by the delamination in the same way, and it will looks as if you see the picture, this exploited vermiculates. So this is the some aggregates. So अशी आपण sand ही पाहिलेली आहे, नदीच्या काठी वगैरे अशा प्रकारची आपल्याला समुद्र सी and sand ही आपल्याला पाहायला मिळते. So in this form like we are preparing the aggregate, that is the artificial light aggregate. And last artificial light weight aggregate is the cider, clinker and bridge. So these cider, clinkers or bridge are the partly fused or sintered particles arising from the combustion of the coal. So in the combustion of coal, these particles are arising, and it is tempered as a cider or clinker or bridge. We can call as a cider, clinker or bridge. And this cider cinders or ciders, we can say, aggregates undergoes high drying, sinkage and moisture movement. So if you see the picture, these are the clinkers. Second picture, if you see clinker, if you see second picture, that is the clinker. So this clinker are the manufactured from as the combustion of the coal, and these are the used for making building blocks for the partition wall and making screening over flat or the for plastering purpose. So up to this artificial lightweight aggregates, we will stop here today. And next part we will see in the next lecture, that is the aerated concrete, we will see in the next lecture. So today we will stop here. So this next aerated concrete part we will see in the next lecture. So wait.